Okay, so we are going to be doing a post-mortem analysis of a long-standing startup. And first, we're going to just do a little bit of sort of background and information, and we'll jump right into it. So a little bit about ourselves again. Jeff and I are doing this for the Battery Pack, just charging monthly. And basically, we plan every month to do either a review of companies, an autopsy of companies, or another kind of dive into companies in a specific field. And with all of these, there'll be a presentation and a video that we'll be making, which are then available to this community, and we'll be putting them online as well. So we aim to support conversations across different players in the field of energy storage, speak a little bit of the unspoken of battery science, things you don't see in a lab, stuff that companies don't really discuss, and share a couple, mostly honestly, share some non-confidential lessons learned, sort of pain points and problems and resources, and discuss what is sort of public with a critical eye and critical thinking. If you have any questions, you can contact us here directly.
And so, also just like a tag in, this is 100% our opinion and our interpretation of what is publicly available. So yes, we may be experts, but we don't know what's under the hood relative to somebody else, right? So just take that, take with what we say with that critical eye, knowing that we know about as much as openly available as the next person is. You can do research. We're just applying our expertise to what is publicly available.
And one of the things, so normally Jeff and I take the notes and publish them ourselves, but since doing the full presentation and the recording is a little bit more work, I would actually like a volunteer to take notes and do the notes on the Battery Brunch if somebody's willing to do that. Is there anyone in the audience that's willing to do that? And if not, we can still do it. It's just a little bit more work for us.
Yeah, Albert, I can do it. I'll just
great.
Website, yeah.
I hear Junie. I don't see you, but I hear Junie. That'd be fantastic,
me,
Junie, if you can do that. Okay. All right, thank you so much. Okay, and we're going to proceed. So those of you that have seen our previous talks are familiar with this slide and maybe bored to death of it by now. But basically, we've done previous talks on a couple different metrics that we think are very important for battery companies. And this one's surviving the valley of death. We're going to just briefly review them each for about half a minute to a minute before we jump into the actual topic, because we'll be using these to grade the company. So again, surviving valley of death is critically important. It's where you take your company from the R&D stage to commercialization, and hopefully on the other side, if you survive through it, you have success as a business and profitability. There's a lot of different ways to go through this, but really the advice is the same for a new startup as it is for somebody going down the valley, which is stay in touch with your markets, talk to your customers, manage your cash flow. I cannot stress that enough. You can't spend money on things you need to do if you've already spent it. Grants are your friend. The DOE, DOD, RPE, SBIRs, STTRs, and Cal grants are a great source of revenue to do the R&D you already want to do and partner with people that you can get expertise that you wouldn't be able to find or afford otherwise. You should target high-value, low-quantity applications to start. Not every battery needs to go into EVs is a very important lesson most people still need to learn. And finally, success for the company does not necessarily mean success for the founders, executives, employees, or investors, and vice versa. Next, Jeff?
Sure. So this one we're talking here, and we graded, we call it engineering into the box. In essence, what it is what are you doing as a startup, or what is the company doing as a startup that will allow tier ones or tier twos or potentially tier threes adopt their technology, right? And this kind of goes into the idea of, if you have a revolutionary technology, are you going to be able to fit into the existing support structure that already exists in the battery space such that adoption is quick, easy, and painless? Or are you on the other side where you've had to reinvent the manufacturing process? And in that case, you're not engineering into the box, right? You're going outside of the box. And one of the things we look at and we grade highly, right, is it's very difficult not only to raise capital, as Aubert mentioned, the surviving the death, but it's as you onboard new manufacturing processes, right, you have a certain amount of capital cost that's going to be associated with developing the scale and the production associated with those new processes or that new manufacturing technique. So we really look to see, are they building such that they can go into what exists out there, such that the resources are readily available and the equipment is readily available such that there's quick roads to adoption.
All right, next.
Pain points.
So then, sure, you take this one. Yeah.
So pain points is basically one is, what is the best equipment? How are they leveraging existing technology? who are they getting materials from? What are the best resources to prototype? This really is, are they overcoming the known or unknown challenges of their chemistry or their industry? And have they gone over what we call those pain points? That could just be, can they supply or produce enough material? Can they get QC down? Can they test correctly to who they're trying to put tech into? What is their reliability of the cells, right? That we're talking about everything in the process. Have they overcome coding? Have they overcome, have they ever done a large roll-to-roll coat would be an example, right, of a pain point. So, the big here thing is the realization that like the last 10% of the manufacturing process is 90% of the work. It's really easy to make something cool. It's really hard to make it over and over again consistently and to scale.
Okay. And the next one is basically matching your technology to your market. And there basically is no silver bullet. Batteries are all very, very different, and there's always a give and take in their performance. Something you'll see a lot in the new things that people are hyping today are the very, high energy new lithium metal, lithium sulfur, high silicon content batteries people are producing. But ultimately, as you push performance, you go up in cost, right? There's just no way around that, especially when you need new equipment and new facilities and new processes that haven't been done before. And there's going to be an enormous amount of QA that you're going to have to go through. And so really, there's a performance metric specification, and there's a cost specification for every market out there, and you just need to match your technology and your price point with what those are if you want to be successful. The case we used in this one is that the battery that goes into a Tesla is not the same battery that goes into a soldier's e-communications device out in the desert for use in Iraq. Right? I mean, one is a very different operating temperature. One really cares about safety. One really cares about cost. One you can charge as much money as you want as long as it works, right? So somebody's sharing a message. Okay.
That's okay.
Oh, okay. Well, we'll get to some of that stuff later. And there's, of course, a lot of caveats in everything we say, where there's always a specific that trumps a general for anything that somebody says. And so, thank you for that comment. But anyway, so basically, grading a company on how well they're matching their technology to their market and kind of staying on track to do that versus someone that perhaps just says we can hit every market, but their stuff doesn't really match it correctly.
Yep. All right. So
and the last one, which I guess there wasn't a slide for, was do we like them? And that's just sort of a qualitative and kind of answer, what we like or don't like about them and why. But that's a very sort of qualitative one. This was the last session that we did last month. Is we went over Solid Power, Qberg, Northvolt, and Soteria, and we made a nice little spider diagram based on the ratings, so you guys can look at that. And kind of going forward, that's how we're going to grade stuff, is sort of with a spider diagram. Because you guys, anyone that's heard our talks before knows how much I like those.
Yeah, and the goal here, guys, is not to give people a hard number of something, right? The goal here is to just kind of show strengths and weaknesses, right? We don't want this to be like they're a 5. No, we want this to be like they have a strength here relative to other people, and that's kind of how this is meant to be. It's not meant to be a hard grading system. It's meant to be a spider diagram of what the strengths and the weaknesses are, is how we as professionals perceive it.
All right, you guys all ready for the reveal of who we're going over today?
I feel like some people already guessed based on the chat.
I've also told people because I can't keep my mouth shut. But all right, here we go. So we're going to be going over Oxis Energy, the recently deceased Oxis Energy.
So they're an exciting company. I think a lot of people here who've been in the battery industry have heard Oxis Energy, similar to Scion Power, right? Amprius, those are names that we've heard around for a long, long time. They've been at it for 15 to 18 years. And if we just switch to the next slide and even look at their company profile, right? They were founded in 2014, so they're 17 years. They got a total of 97 million, right? And if you look at it, they actually had some very interesting, right? Like Samsung Ventures put an undisclosed amount. Say So Golf has been in them twice for almost to the tune of $45 million, right? They don't have a big competitor pool. If you compare this to like someone like Amprius, who's now competing with like Innovate, Scylla, Ansno, Enovix, right? Like their competitor pool is actually a relatively small bunch. It was like 2 or 3 other companies. So this is a really interesting one because I always thought Oxis as a company was just this very interesting, like gung ho. Like they were always pushing that they can get data. I felt they were doing a lot of things right, but kind of as you can show there, when they announced that they were going to have a 550 watt hour per kg battery and they were able to achieve 471, they were unable to secure funding, right? And that creates this interesting story of where they were pushing a lot of really good data on a large pouch size, but they just weren't able to hack it, right? And there was clearly something there that was the nail, so to speak, in the coffin for Oxis. So this is cool, and I think Aubert found this really cool when I first showed it to him. Oxis was willing to put out a spec sheet, which is actually really rare for any startup to sit out there and put actually full cell specifications. Now, there is a caveat, which is they do not support orders, so this could be like hand wavy at best. But if you look at it, right, there's a lot of cool things here, right? So like, for example, they're telling you what their operating window is, right? Which if you're working in lithium sulfur, this is what I would be operating in, so to speak. If I would program my testers, I would be immediately like, all right, Oxis clearly did this for a reason. I should be operating in the same window. They tell you how many amp hours, what the watt hours per kg, peak discharge rates, and like you can see interestingly here, right? Just to give a background, right? Lithium sulfur batteries, if you think lithium metal is hard and you think silicon is hard, lithium sulfur is a whole nother animal that has many, many problems. So not only do you get all the lithium metal problems of dendrite formation, pitting and plating, uneven distribution upon plating, excessive SEI formation, you also actually get a ton of other host of problems from the cathode. So quite simply, in the most basic of terms, a sulfur cathode is a conductive matrix with sulfur impregnated into that matrix. The reason for that is sulfur is 10 to the negative 16 Siemens per centimeter in conductivity, and when it becomes lithium sulfide after you discharge it, it's 10 to the negative 32. So there is no way you could ever feasibly put elemental sulfur by itself with like 2% carbon black as a cathode. The battery would actually never cycle. In addition to that, it's not an oxidation reduction chemistry, it's a conversion chemistry, which now brings up another host of issues, which are when you actually discharge the cell and run lithium, you have a cleaving action where S8 cleaves all the way down from Li2S8 to Li2S. And the problem with it is Li2S4 to Li2S8 are all soluble in your electrolyte. So that means they will actively try to leave the cathode upon cycling to make a chemical equilibrium with the solvation in the electrolyte, and then start redepositing everywhere in the cell. So not only do you have excess formation of SEI on the lithium metal, you now have lithium sulfide depositing on the lithium metal, corroding the surface, compounding the excess. So these are a ton of issues, and it's actually, interestingly enough, you can see it in their cycle life, and this is one of their pain points. They could never get more than 60 to, as they were saying, they were never confident of getting more than 60 reliable cycles, right? That's how I view this. And the other issue you see here, right, is they have a very interesting spread, right? And you can tell that lithium metal corrosion actually is one of their major pain points in what they were doing. Yes, they could get 300 watt hours per kg. Yes, they could get 400 watt hours per kg. Yes, you might be able to discharge it relatively quickly up to 60, but they don't actually tell you what the rated capacity is at those rates. But one thing you do know is that they will never charge faster than C/4. Right? So that's a clear indication that they either can't strip lithium fast enough off the sulfur and they're running into impedance that way, or it's telling you that they're running into huge issues and had huge pain points on the anode. And there's a little bit more about that too, actually. If we go to the next slide, right? This one it kind of represents it. So Oxis, I think, Aubert, correct me if I'm wrong, you found this in 2016?
Yeah, this was a late 2016 NASA presentation where they gave cells to NASA to evaluate.
And then they had their own internal presentation that they showed off in 2015 or so. And you can see here on the left, they're showing a pouch and they're saying, hey, we can do 1,100 or 1,000 cycles, right? If you try to normalize, when it went over 100 and bring it down. But then you see NASA on the right says, no, they can only do maybe 100 cycles. They fall off really quickly. This is one of those things where, when I started doing research into Oxus, and I'm sure Aubert saw it, is that they fell into one of the things we try to tell people to not fall into, which is do not publish data trying to represent it as a full form factor cell. Because the reality is that they presented data showing that they have long cycle life, but the reality is when they went to NASA and they probably went up to a multi-stack pouch at relatively low rates, there's no way they were able to get even close to what they were able to do. And this is actually probably the biggest pain point of every startup I've ever seen, from Oxis to Scylla to Innovate to Solid Power, even to Polyplus or Liano, is scale, right? It is very easy to take a single layer cathode or two single layer cathodes and wrap it around a double sided lithium metal anode. But when you start coding on the order of meters to hundreds of meters, right? You can go back.
No, I'm sorry. I was trying to get to the. I wanted to see chat and I misclicked.
No worries. Once you start getting into the order of hundreds of meters to other binder migration, where does your large particles fall in the slurry relative to your smaller particles? What is your current share suddenly becomes this thing you never had to deal with because you were so making coins and like small stack pouch cells, right? And Aubert, correct me if I'm wrong, but this I would say is probably the biggest pain point is when you go from that single layer pouch to a 10 stack.
Yes.
Go ahead, Aubert.
Oh, you want me to talk about it or skip ahead to the?
No, talk about it.
Okay. So, we see a lot of data at Spectra Power. We work with a lot of people, and typically the two kind of pain points for most startups are they're going from coin cells, which have 20 times excess lithium and 12 times excess electrolyte compared to normal full scale cells. And they're going from that to single layer pouch, which still has, I forget the exact numbers, it really depends on the form factor and stuff, but 6 times excess electrolyte, right? And then going from that with really, really good, long, consistent results in your coin cells to your single layer pouch cells, and then to a real cell, you really see what fails. And that's just pretty common in our experience at Spectra Power.
And to Dean Frankel's point about miscategorizing a few companies, I don't think we are. There's not a lot of companies out there that will hand you a 20 amp hour pillow pouch and have you test it themselves. Solid Power, for example, makes these huge 20 amp hour pouch cells. Even Oxus was making 16 amp hour pouch cells, and the data is out there publicly available, at least for Oxus, from Airbus and NASA. And biggest complaint, and I talk to a lot of national labs, so this is a issue across a lot of different companies, is that the performance they claim in their decks or in their meetings never reach the rated performance they see in the end product handed over for third-party validation. That is by far the most consistent complaint I have seen in the battery industry. And it is by far the most consistent crux. And it all relates to, can you do it consistently at scale, right? You can make 10 grams of powder, but when you need to make kilograms of powder, right? You think about the little furnace they have, it's small, kinetics are relatively controlled in a small space. Now, amplify that up to something the size of a large water tank, everything changes. And that's, unfortunately, that is true regardless of the company that is trying to do it, right? It's something everybody faces. So we can kind of push on to this next one too, because I think we do want to have a little bit more of a discussion. And Aubert, you want to take on this one?
Sure. So there's a couple things here we wanted to go over, but basically, are they engineering into the box or not? And in some ways, yes, and in some ways, very much no. And Jeff's a little bit more about the expert on the patent issues here, but if you can look down here, connecting contact leads to lithium-based electrodes, you'll see that they're doing something that's not quite standard. And they have a lot of patents, which is very good. But when you look at them, a lot of times they're doing things that are radically different and that deviate from standard lithium-ion, lithium metal production in ways that create additional pain points for them. And I think that was one of the big problems, is that they had a lot of trouble being able to take their unique technology and actually get the manufacturing and the equipment and the quality with their new processes and new equipment.
Right, like if you think about it, right, like if you have a pure lithium metal anode and there is no copper backing, one, and Aubert and will account for this, people will not slit you lithium metal foils. That is a no-go from the get-go. So people will not, like, you could talk to RIT, you could talk to UMISH, you could talk to Spectra Power, you could talk to like the Battery Innovation Center, Coulometrics, you name it. They will not put lithium metal through their slitting machine because it is such a soft metal. It gunks up all of the mechanical components of that device, and that requires someone to clean it, and it's just too much of a headache, so they won't do it. Right, and this is why we talk about engineering into the box. The cathode was a complete roll-to-roll process, and from that end, right, they mixed powders, they coated it onto a film. They completely did everything standard practice, right? It went through drying ovens, it was densified, it could be slit, it could be controlled. There's no issues, but a lot of the issue here, just beyond just the manufacturing of a pure lithium metal anode, is just when you run pure lithium without any kind of backing, once you create a hole in that film, you're done. I don't think there's any recovering from just like the issue. And then, I don't know, Barrett, like one thing I ask you on this actually is, how much lithium do you think you would need to run to retain the structure of the lithium metal anode?
It's a hard question, but the answer is a lot. We've had a couple different projects where people wanted us to tab directly to lithium, and it's always a problem, and the electrodes always fall apart, and there's a lot of bad reactions that happen at the interface between the tab and the lithium that end up being issues depending on the other chemistries in the cell and the electrolyte. We've actually seen a lot of the really high-performing additives become a real problem when the thing that you're tabbing to is lithium and not copper. But yeah, it was definitely one of their pain points, and it was not engineering into the box per se. And I encourage anyone that wants to go look at these patents. They had some interesting stuff that they did, and we'll see, I guess, if any of the other companies pick these up and continue with their methods or equipment.
Yeah, I mean, there was one I think that always interested me is they ran similar to Adrian Yao, if you guys see him for, he's the current CTO, the name is NPower, and they actually, Oxis runs a similar gradiated electrode, and that was their way of trying to deal with polysulfides. Instead of running open large particles the surface defines, they flipped it and ran large two fines, such that it was acting as a mechanical mechanism to help hopefully block the polysulfide shuttle. And I thought that was a pretty cool little thing, but I'm sure I don't think Adrian's here, but like if you look at it from the standpoint, running gradient electrodes is not a simple manufacturing process. There's literally entire companies built around running different layers of different porosities on an electrode, and in it itself is its own giant project. So when we talk about this engineering into the box, right, like your goal is with these startups or like anything else, like when we look at them is you need to have a clear path to production, right? Engineering into boxes, do they have a clear path into production? And unfortunately, Oxis, they had one for the cathode and probably the electrolyte because you're just mixing chemicals at that point. But the anode, there was no clear path, right? There was no way they were going to be able to walk up to anybody's door and get that adopted quickly or demoed quickly without having to put in the capital themselves. And then you have to develop the equipment and the specialty equipment and hire the engineers, and that in itself has its own large CapEx cost with it.
And something I would just like to caveat, because I actually have gotten some feedback on ultimately the way that you could be very, very successful is by leapfrogging everyone else, which actually requires that you don't engineer into the box, but then you have to develop all your own equipment and process and everything else, and it's just exorbitantly expensive. And so if you have the resources to do that, you have a new method of manufacturing equipment, tools, and process, it is something that can be successful. But for a small company or a startup that needs basically quick, fast results for cheap, you just can't do it. It's almost like a death sentence if you're trying to do that, because then you're fighting everything from your materials while having to deal with all the other manufacturing and scale up problems basically by yourself, versus being able to ignore some of that work by doing what other people are already doing.
So let's carry on.
Okay. So matching tech to market. And I think, so one thing I'd like to just say about this real quick is Jeff and I have shared a couple times before a larger version of this sheet on the right, matching a bunch of different battery chemistries to their manufacturing steps and kind of the cost, and then to the different chemistries sort of basic performance metrics, their watt hours per kg, their cost, their safety, their charge rates, things like that. And then from that, matching them to their applications. So this is just a copy of that sheet, which the plan for that is to actually be made available to the entire community probably at the next month's Battery Brunch, if not sooner. There might even be an announcement about that later today after the brunches, the formal this part of the brunch ends from Linda or Yen. But basically, looking at lithium, sulfur, you kind of see what markets they can go into and what they can't. And really the things that Oxus was matching their stuff to, for the most part, matched pretty well. They were looking at planes, aerospace, drones. They were looking at the light and medium and heavy trucks. And these are all places where their technology would really match the application. The performance metrics and the cost metrics really could have been successful if they were able to get some of these things working the way they were hoping to with their different cell specs.
So,
do you want to add anything to that, Jeff?
Yeah, so actually the biggest, the biggest issue for Oxus was cycle life. Yeah, that was single-handedly the biggest issue, right? Like they targeted all the correct applications. Military, they literally went hard on military in the defense space. But the problem, right, is the military needs 220 cycles. That is what the DoD tells you. They need 220. If you can get 220 cycles in your current new technology, the DoD will take you if you can show better performance on an energy density level or a volumetric energy density level, grav and volume. So, they actually did a really great job. Like, they never oversold themselves. One of the things we see all the time from startups, and this is why I'd actually rate Oxus decently high in matching the bullet, is they never oversold what technology they would naturally fit into, right? When they say electric vehicles, they're talking about lightweights from buses to lightweight trucks, right? And that makes total sense. The whole thing is terrible volumetrically, but it's fantastic gravimetrically. But someone is slurping. Yeah, something like that. All good. We'll just talk over it. They did a great job. So, honestly, I would rate Oxus very highly. I don't think. Well, let's see if we can't. I don't have controls.
Okay, we'll just talk over it. It's okay.
Yeah. So, the reality is that they did a great job. And in this area, this wasn't the reason for their down collapse. There was no reason that it was related to them trying to oversell for application. It came down to other factors that we were talking about earlier.
You think maybe Sanjay's computer is having some issues there?
It looks like it's Sanjay Patil's. Yeah, maybe.
Sanjay, you want to
mute yourself?
There we go.
Perfect. Thank you. Back.
Yeah.
Okay, we thought the noise was coming from your computer. It's at least that's what it was showing on my screen.
Sorry about that. But yeah, no, like okay. This to no fault. They didn't oversell in this area. This was like to no fault the reason why they went under. Right? I think largely so it was really due to other things. They did really well getting money. They did really well targeting their application, but
Since we're kind of already doing the summary, I just jumped ahead to the next one. One quick note on the last one is I forget the aerospace company, but there was an aerospace company they were working with very closely that was really, really sad that they went under. They were apparently the batteries worked really well in that application, and that was one of the things we saw when we were doing the research is a lot of the people that they were prototyping stuff for their specific applications were very happy with the batteries. And that's a really good sign. If you have happy customers willing to buy your stuff, that's a really good thing. They just weren't able to hit their next investment round, right?
And I think, and from that point, right, like, do we like them? It's kind of like a soft yes. That's how I view it, right? Like, they're to me, they were always an inspiration, like a beacon of light challenging this new technology. But I think Aubert and I both agree we probably would not have done it their way.
So, and to the point of the comment in the slide, you'll see the surviving the valley of death. That's grading them on the financial point of view, and they got a 0 on that. So yes, we did grade them about as harshly as we could on that metric.
I mean, right? Like when we talk about raising money, right? 100 million is doing well to raise money. It depends on your cash flow. Now, did they survive the valley of death with that? No, we rated them a complete 0. They were able to get money, but they just couldn't keep getting it because the reality was they made a lot of promises and certain key performance metrics never improved. And that's a lot where you see them taking large hits on pain points, right? And engineering into the box. They couldn't overcome those two fundamental things. There was no way they were going to get, unless they built out manufacturing facilities themselves, there was no way they were going to get into large-scale production for any of these applications. And until they figured out how to get over the pain points of cycle life from using a pure lithium metal anode and dealing with all the issues of lithium metal anode with sulfur trying to kill the lithium metal anode, there was no path forward for them, right? So there's nobody who, after a certain amount of money, people started to realize that it's been 17 years and they haven't figured it out. This just doesn't make sense anymore, right? But I always liked Oxis, actually. I thought they were just like this cool little beacon of light doing the crazy chemistries that nobody wanted to touch because everybody was more focused on the near-term lithium metal and silicon anodes and solid state as the primary adoption route. So I don't know. What do you think, Aubert?
Yeah, no, I think it's definitely. I think we're going to see a lot more battery startups. They've been getting a lot of money recently, and what that means is they're scaling up. And I think in the next couple of years, we're going to see a lot of them ultimately fail as they're not able to keep up with their money needs. And I think there's going to be a lot of lessons learned here. And this is just sort of one early example of a fairly long-standing startup that did a couple things right, a couple things not right, and learn from the things they did well in this sort of their tech matching to market, and learn that you just that next round of investment is the single most important thing in most cases, and you just have to be able to hit it.
That means hitting technology advancements or anything like that, right? You got to hit whatever they want, right, to get that next round of funding. And if that means more cycle life, that means more cycle life. If that means more energy density, that means more energy density. If that means proving you can build out 100 kilograms of material, that means proving out you can produce 100 kilograms of material. So,
and then really quickly, we're going to sort of preview next time, and then we're going to open it up the floor to questions and discussion.
So next time we will be, on who's doing it right is to FEC or not to FEC. We will be talking about what we dubbed the Swell Squad. So we'll be going over quite a few companies in that space and our viewpoints on whether they're doing it right or wrong, giving the bullish and the bearish cases.
Okay.
So anybody have any questions? I mean, we did this one intentionally only once. We could actually have some time to do questions, whereas last time we ran into the issue of just it went over. But, does anybody have any questions they want to learn or any comments?
Hey Jeff, you briefly mentioned about the competition pool between different battery companies. Are those generally divided by their tech match, like their own sort of applications for their own chemistry?
Usually it's two parts. Usually it's the people doing the most similar technology process as you, and then secondarily also people going at the same applications. So a lot of times those overlap because if you're using the same chemistry, you kind of have the same constraints and attributes. Sometimes they don't. So you could have two silicon companies going for different applications. It's unusual, but that does happen. But typically, competitors are like somebody else doing a very similar technology space.
Yeah, and I mean, you guys have to understand too, right? Like we listed two competitors, but the crazy thing, right, is the amount of auto OEMs that want lithium sulfur actually is relatively high. Like Mai from General Motors in their R&D battery lab, or May, she is a active contributor to the Battery 500 for lithium sulfur and an active contributor to like annual merit reviews for advancing lithium sulfur technology. Daimler came out with this huge presentation at Auto Day, I forget what it is, about how lithium sulfur would enable them to run lighter weight composites in the frames of the cars because they don't have to worry about the support structures as much. So there was clearly a lot of interest, right? It's just Oxis couldn't overcome some of the fundamental pain points and engineering issues that they were running into, right? So there's definitely a lot of interest out there. And when you talk about competition, right, especially competitors, right, if you think about it, it's usually customer driven, right? So if we're the ones buying it and I run Stellantis, right, and Stellantis hasn't been into an EV company, Stellantis is not going to look at Amprius, Enovix, Enovate, or Scylla any differently from each other. They're going to look at this box, and it's going to be a black box, and they're going to say, do you hit the performance metrics I need to get me ahead? And they're going to have their own team of engineers that say, does it decrease the weight of the overall structure so I need less steel or aluminum to hold up the framing of the battery banks? What are the temperatures of the cells as they cycle? How much thermodynamics do I need to account for in my heat transfer exchange mechanism for the cooling? All of those things are going to be driven by it. So, yes, people tend to clump first towards their chemistry or stuff and then go to the application. But from the application side, they kind of look at as you say you have a silicon anode. Do you meet these hard performance requirements? Yes or no? Right? And if not, they'll go next door. Right? It's a very much a competitive game because it's pretty cut and dry when you get to the apps. It's do you meet their battery requirements? Pretty cut and dry.
Anyone else? Questions, comments, rebuttals, things you disagree with us on, things we didn't cover?
We're more than happy to have an active discussion. We're not always right.
Yeah, I have a small question. I have an add-on technology for battery systems, actually. It's a location-enabled battery, a battery which provides location. Now, this is an add-on technology, and I have got USPTO issued patents on it, and it is